Good morning, good afternoon, or good evening, Mastery Algebra peoples. I'm Mr. White. This is lesson 5-5. This is the intercepts method. What we're going to do is we're going to look at computing the x and y intercepts of a linear equation, and then we're going to use those intercepts to actually graph that linear line. First, we need to figure out or remind ourselves what the definition of an x-intercept is, and we have to define the y-intercept of a line. So the x-intercept, that is where a graph crosses the x-axis. What we can do is we actually can let x equal a number and then comma 0. The y-intercept is just flip the 0 and the number alone, and it's where the graph crosses the y-axis. So if we draw a line on the graph and indicate the x-intercept, we'll just take right here. We know that this is the x-axis, this is the y-axis. So this point right here in green, okay, that's going to be our x-intercept. That point is, if you notice, some number here that's x, and then we did not go up or down, so it's 0. So that point is x, comma, 0, or positive x since we are on the positive side. On 4, if we give the x-intercept as an ordered pair, we can just, instead of saying what we did, x comma 0, we can make up a bunch and say, well, maybe that's 2 comma 0. Maybe that's 5 comma 0. If we switched it around, maybe it was negative 5 comma 0. Just notice that each of those points there actually has 0 in for the y coordinate. If we draw another line on the graph and indicate the y-intercept, so let's draw a line this way with a positive slope, we know that instead of going on the x, this green marker now is on the y, so this is our y-intercept. Okay, that point, if you notice, we're not going over left negative x or positive x, but we're just going up, so this is 0 comma y. So some order pairs that we could actually put there are, instead of 0 comma y, we could do 0 2, 0 4, 0 100. Okay. If we went down, it would be 0 negative 5. So notice each one of those has a 0 for x. Okay. So those are x and y intercepts. So 7 through 12. What we're going to do is we're going to calculate the x and y intercepts given the following linear equations, and then we're going to list the intercepts as ordered pairs and graph. Okay. So if we start with number 7, 5x plus 3y equals 15. And the reason why we look at X-Intercepts method or graphing by intercepts is, if you notice, each one of these equations is pretty much in standard form with the x and the y on the left side or on the same side. So instead of actually solving for y and then graphing, what we can do is let's use x and y intercepts. So if I draw this little t, if this is my, let's just say left side, this is my x-intercept, and the right side will be my y-intercept. Okay. Back to the definition that we just looked at for x-intercepts. What do we know? All x-intercepts, y is 0. So if we go y equals 0, what we're going to do is we're going to plug in 0 for here, which 3 times 0 is 0. So we're going to be left with 5x equals 15. If you divide by 5, we get x equals 3. Okay. So if we write that as a point or an order pair, we know that we get 3 comma 0. If we do the other side on the y-intercept, we know that x is equal to 0. So now we take this 5x, and that's going to be 0. So we're left with 3y equals 15. If you divide by 3, we get y equals 5. So then our coordinate is 0, we plugged in, so 0 comma 5. So using those 2 points, if we go over at least 3, 1, 2, 3, okay, and we put a point on the x-axis, so that point is 3, 0. If we go 0, 5, 1, 2, 3, 4, 5, put a point, what we can do is we only need 2 points to connect a line, so we take our 2 points, and now we have a line. Bang! So what we can notice is, based on that, if we were to actually solve for y, we do have a negative slope, okay, and we do have a y-intercept of 5. Number 9. So over here again, this is our X-intercept. This is our Y-intercept. So our X-intercept, Y is 0. So if Y goes in for 0, then that 3Y becomes 0. So we're left with negative 4X equals 12. If you divide by negative 4, we get X equals negative 3. So our point is negative 3, 0. If we do the other side, we're going to input X equal to 0. So the negative 4X becomes 0. We have 3Y equals 12. So Y equals 4. So input 0, out comes 4. So we have 2 points, negative 3, 0, and 0, 4. If we graph those, let's go over left this time. 1, 2, negative 3, 0. And we're going to go up 0, 1, 2, 3, 4. Put a point, and graph our line. And there we go. Okay. This time, if you notice, if we were to solve for y on 9, we'd actually have a positive slope. And again, our y-intercept would be now 4. Okay, one more, number 11. If we draw our t, again, x-intercept, y-intercept. On the x-intercept, if y equals 0, okay, this 3y becomes 0. So we're left with 6x equals negative 12. Divide by 6x equals negative 2. So our point is negative 2, 0. So we can go over 2 slots, put a point. We do the y-intercept. X is now 0. The 6x, if we plug in 0, becomes 0. So we're left with 3y equals negative 12. Divide by 3 and you get y equals negative 4. So 0, negative 4 is our other point. This time we're going to go not left or right. We're going to go down 1, 2, 3, 4. We have our 2 points. We can connect the dots and graph. And there we go. Go ahead, hit pause. We're going to try 8, 10, and 12. Check back with me in a few minutes. Go. Alright, welcome back. On number 8, you should have gotten an x-intercept of 4, 0, a y-intercept of 0, negative 7. On 10, you should have gotten negative 9, 0 for the x-intercept, and 0, negative 3. And on 12, you should have gotten negative 6, 0, and 0, 2 for the y-intercept. Alright, next page. Same thing on 13, 14, 15, and 16. Graph each equation using the x and y-intercepts. Be sure to show your work. Go. Alright, welcome back. If you check for 13, you should have gotten negative 4, 0, and 0, 6. 14, we should have gotten 6, 0, and 0, 4. 15, you should have gotten 2, 0, and 0, negative 5. 16, negative 5, 0, and 0, 4. Make sure you have the proper work. Make sure you ask if you have questions. Number 17. Alright, graphing a line that matches each description. So we do have a y-intercept of 0, 3. So if we take our x and y coordinates, if we go up to 0, 1, 2, 3, and we put a point. And if it doesn't have an x-intercept, so if it doesn't have an x-intercept, we know it's not going to cross the x-axis. So the only thing that we could do is pretty much have this line that goes this way through 3. Okay? Well, if we notice that, we need, if we're going to write an equational line, okay, y equals mx plus b, okay, that is a horizontal line. The horizontal line has 0 slope or no slope, so it's not changing. So if we go y equals 0x plus b, well, we know this b is already given to us. It is 3. So we have an equation here that is y equals 3. Or our line only goes through what axis? Y. So we can look at our point and say y is equal to 3. 18, we have x-intercept of negative 2, 0. So we're going to go over to negative 2, 0. Put a point. If we have an x-intercept of negative 2, 0, and it doesn't have a y-intercept, we know it's not going to cross the y-axis. So this time we're going to draw a line straight up and down. For slope-wise, we know that doesn't have a slope. It is undefined. So we can look at, instead of this y equals mx plus b, we have to look at in terms of what axis really does it go through. If it goes through the x, we can look at our coordinate and say, well, what does x equal? And the fact that x equals negative 2 is our equation. Number 19, write an equation of the line that passes through the given point and is parallel to the graph. So we need to understand that when it says parallel, we need to know that parallel means that it's going to have the same slope. So if our equation, which it is in y equals mx plus b, we know our slope is 3. So our other line that we need to find is has a slope of 3, and then we need to find the y-intercept. So if we plug in the point that we have and use y equals mx plus b, we know that the y is 3. We know that the slope has to be 3, and then we can input the 1 for x, and we're going to solve for b. So if we get 3 equal to 3 times 1, which is 3, plus b, all we have to do is subtract 3, and you get b is equal to 0. So the equation that we need is our y is equal to 3x, which is the same slope, or parallel slope, plus 0. Or you could leave it as y equals 3x. All right, number 20. We have a point that's 1, 3, but we need to find its parallel to y plus 2 equals 4 times x minus 1. If we notice, this equation is not in slope-intercept form. So if we distribute the 4 through, we get 4x minus 4, and then if we subtract 2, we get y equal to 4x minus 6. All we really need is that 4. So the parallel slope that we're interested in is m equals 4. Okay. So we take our same point that we had on 19, 1, 3, and we're going to input 3 as the y. Our slope now is 4 times the 1 for the x plus b. So we get 3 equals 4 plus b. If we subtract 4, we end up getting b is equal to negative 1. So writing our equation, we know that the slope has to stay the same. So we have y equal 4x, and then minus 1. All right, 21. The point is 0, 0, and y equals 2/3 x plus 1. Go ahead, hit pause. Try 21. All right, welcome back. If you notice, by plugging in 0, 0 for the point with the slope of 2/3, you should have gotten a y-intercept of 0. So our equation that is parallel to the one above is y equals 2/3 x plus 0, or just y equals 2/3 x. All right, 22, 23, and 24. We're going to actually do 24, but we need to write an equation of the line that passes through the given point and is now perpendicular to the given equation. Based on previous lesson, our perpendicular slopes are negative reciprocal or opposite reciprocals of each other. So we need to take this equation, we need to write it in y equals mx plus b form. So if we distribute this 2 through, we're going to get y plus 1 equals 2x minus 6. When we subtract 1, we get y equals 2x minus 7. So our slope that we're interested in is 2. Okay? The perpendicular slope is the opposite reciprocal. So negative or opposite, you could look at it as being negative. Okay? And the reciprocal of 2 over 1 is 1/2. So we're going to use the perpendicular slope as negative 1/2. Now we just do what we did on 19, 20, and 21. We're going to take 0 for the y, plug in negative 1/2, times by 5 plus b. 0 equals negative 5/2 plus b. If we add the 5/2 over, you get b equals positive 5/2. So our equation that is perpendicular to the one that we were given, but is going through the point 5, 0, is y equals negative 1/2 x plus 5/2. All right, go ahead, hit pause. Try 22 and 23. Go. 22, you should have gotten y equals 1/3 x plus 0. And 23, the slope that was perpendicular was 2. Therefore, we got y equals 2x plus 8. That concludes 5-5. Don't forget any bookwork that you have. Remember, do your best, forget the rest. Bye for now.